Alright, so today we'll look at the equation of a circle passing through three non-collinear points. So what you need to know is that when a circle passes through a point, then that point lies on the circle. So the point therefore satisfies the equation of a circle. And then next, to find the equation of a circle passing through 3 points, each point must satisfy the equation of a circle. And that means the general equation of a circle. So substitute each of the points into the general equation of a circle to form simultaneous equations, and hence we solve them to find the unknowns. And then finally substitute back the values of the unknowns into the general equation of the circle to find the required equation of the circle. So this will make sense through examples. So the first example we're going to look at is a question from UNEB 2020, and this was question 10. So being told that a circle passes through the points 1, 3, 2, 2, and 5, 7. Find the equation of the circle. So that's what we're being told. So let's sketch this. So now we've been told it passes through 3 different points. So one of the points we shall label as x, the other one is y, and the other one is z. So point x is 2, 2, point y is 1, 3, and point z is 5, 7. So as you can see, this circle has a center. Now since all those points lie on the circle, it means that the lines connecting towards them from the center shall be equal to radius. So that's what we have right now. So now from the general equation of a circle, we can see that this is the general equation. So now it's also true in each of the cases. So now using the point x, it is true that if we plug in x, x shall satisfy the equation 2 minus a squared plus 2 minus b squared is equal to r squared. So this shall be equation 1. Then we shall also see that when we look at the point z, we shall have it also satisfying the equation 5 minus a squared plus 7 minus b squared is equal to r squared. So that shall be equation 2. Then you can also lastly see that the point y satisfies the general equation, so we'll have it as y minus a squared plus 3 minus b squared is equal to r squared. So now that we know these 3 different equations, we now need to work this out to actually find the values of a and b and r. So first of all, we can see that since all the equations equate to r squared, we can equate equation 1 and equation 2. So let's first equate equation 1 and equation 2. So you can have it this way. So when we expand each one, this is what we'll get. So the next step we can see is that here, a squared and b squared will cancel with the a squared and b squared on this side. And what we'll be left with is this. Then 4 plus 4 is 8. Then we remain with negative 4 minus 4b. Then here we can set 25 plus 49 will give me 74. Minus, obviously, we can say this negative 10a will remain minus this 14b. So next, when I collect like terms, I'll have 6a plus 10b being equal to 66, of which this shall be the equation 4. So let's set this be equation 4. So next, I will equate equation 1 with equation 3. So now this is what I'll have. So when I equate the two, then when I expand, this is what I'll get. So next I can see that a squared b squared will cancel from both sides, and then I'll have 8 minus 4a minus 4b being equal to 10 minus 2a minus 6b, of which when I simplify this further, I'll have this. So as you can see here, I remained with negative 2a plus 2b being equal to 2, but I can divide all sides by 2. Then eventually I'll have negative a plus b being equal to 1, and this shall be equation 5. Alright, so now that I have those 2 equations, I can now see that the next step is, now that I have equation 4 and equation 5, I'm going to make b the subject in equation 5. So you shall see that b shall be equal to 1 plus a. So now that I know the value of b, I'm going to substitute for b into equation 4, of which I'll have 6a plus 10 into 1 plus a shall be equal to 66. So multiply the 10 in and you have 10 plus 10a. So now when I collect like terms, I'll have 10 plus 16a being equal to 66. So this means that 16a shall be equal to 66 minus 10, which is equal to 56. So a is 56 divided by 16, which shall give me 7 over 2 for the value of a. Now that I know the value of a, I can now also find the value of b. Now remember that this is what we actually have right here. So b shall be equal to 1 plus 7 over 2, of which b shall be equal to 9 over 2. So now I know the value of a and b, and that means that I now have the coordinates of the center. So the next step shall be to find the value of the radius. So how am I going to do that? I'm going to substitute for a and b into equation 3. So in this case, I can use any of the first 3 equations. I can use equation 1, equation 2, or the equation 3. So I've chosen equation 3 in this case. So when I plug in this to equation 3, I'll have 1 minus 7 over 2 squared plus 3 minus 9 over 2 squared being equal to r squared. So this will give me negative 5 over 2 squared plus negative 3 over 2 squared being equal to r squared. So when I square those brackets, I'll have 25 over 4 plus 9 over 4 being equal to r squared, which shall give me 25 plus 9 over 4, which is 34 over 4 is equal to r squared. So r shall be root of 34 over 4, which is the same as root of 34 over 2. So now from the general equation of a circle, I can now find the final equation. So we know the values of a and b, we know the coordinates of the center, and we know the value of the radius. So we're going to plug those in, and this is what I'll have. So now when I expand this, bracket here, I'll have x squared minus 7x plus 49 over 4. Expand this and I have y squared minus 9y plus 81 over 4 being equal to, this will now be 34 over 4. So next, I can actually see that I can actually collect some terms that are like together. 49 over 4 plus 81 over 4 will give me 130 over 4, of which when I bring this to this side, I shall have this subtracting that, which shall give me 96 over 4, which is equal to 24. So the equation of the circle shall be x squared plus y squared minus 7x minus 9y plus 24 is equal to 0, and that is the answer they wanted. Right, so next question, question 2. Find the equation of the circle which passes through the points -1, 4, 2, 5, and 0, 1. So we're going to do the same thing here. So we first sketch, and then you can see that the 3 points can be placed on the side. So we shall name them points PQR, and then that is the center. Then you can see that each of the points join the center with the radius. So they have something in common. So from the general equation of a circle, this is what we have. We can see that it is true that we will have -1 minus a squared plus 4 minus b squared is equal to r squared. Then it is also true that 2 minus a squared plus 5 minus b squared is equal to r squared. Then lastly, it's also true that 0 minus a squared plus 1 minus b squared shall be equal to r squared, and that shall be equation 3. So now we're going to equate equation 1 and equation 2. So this is what we'll have. So when I open and square both sides, this is what I'll have. So next, simplify further, and I'll be left with 2m plus 17 minus 8b being equal to -4a plus 29 minus 10b. So when I collect like terms, I have 0 being equal to -6a plus 12 minus 2b, of which the equation shall now be equal to 3a plus b being equal to 6. So what happens is, in this case here, I actually ended up dividing all sides by 2 to simplify this further, which gave me 3a plus b being equal to 6, and that shall be equation 4. So next, I'm going to equate equation 1 with equation 3, and this is what I'll have. So when I expand this further, I'll be left with this. So I have 2a minus 6b being equal to -16, of which divide all sides by 2, and I'll have a minus 3b being equal to -8, and that shall be equation 5. So now next, I can see that in equation 5, to now solve these two simultaneous equations, I can now make a the subject in equation 5. So a shall be equal to 3b minus 8. And then substituting for a into equation 4, this is what I'll have. So I have 9b minus 24 plus b being equal to 6. This shall be equal to 10b being equal to 6 plus 24 shall be 30. So b shall be equal to 3. So substituting for b into equation 5, I'll have this. Eventually, I'll have a minus 9b equal to -8, of which a shall be equal to 1. So now I know the coordinates of the center a and b. So the next step is to find the radius. So I've chosen to substitute for a and b into equation 3. So remember, you can choose any of the equations, equation 1 or equation 2, but I've chosen equation 3. So now when I plug those in, I'll have -1 squared plus -2 squared being equal to r squared. So this is the same as 1 plus 4 being equal to r squared, of which r shall be equal to root of 5. So now from the general equation of the circle, now that I know the radius and I know the coordinates of the center, I can now find the general equation of a circle. So plug those in, and I'll have x squared minus 2x plus 1 plus y squared minus 6y plus 9, of which here 1 plus 9 shall give me 10. Then bring this here, and I'll have it as 10 minus 5, of which eventually the equation of the circle shall be x squared plus y squared minus 2x minus 6y plus 5 is equal to 0, and that is the answer they wanted. The next question is a question from UNEB 1996, and this was question number 11. So being told to find the equation of the circle circumscribing the triangle whose vertices are A 1 3, B 4 negative 5, and C 9 negative 1. Find also its center and radius. So this is also an equation that needs the knowledge of non-collinear points, but it's just given in a tricky way. So now we've been told that the circle circumscribes a triangle. So this shall be the sides or the vertices of a triangle. So now this is actually clearly the same as what we've been doing. So now we shall be looking at those collinear points, those points on which the triangle touches the circle. So those are the points we shall be interested in. So we have the points A, point B, and point C. So we can also see that we can actually join a line from all those points towards the center, which shall give us the common radius. So we can see that also from the general equation of a circle, we shall have 1 minus a squared plus 3 minus b squared. Using point A, this is what we have for equation 1. And then using point C, we can see that we have 9 minus a squared plus negative 1 minus b squared is equal to r squared. Then lastly, using point B, we can have 4 minus a squared plus negative 5 minus b squared is equal to r squared. So now equating equation 1 and equation 2, we will have this. So expand both sides. The next we can see that a squared and b squared cancel, and this is what we remain with. Then collect like terms, I'll be left with this. Now the next thing is I can divide all sides by 8, and I'll be left with 2a minus b being equal to 9, and that shall be equation 4. So now equating equation 1 and equation 3, I'll have it this way. So simplify this further, and I'll have 6a minus 16b being equal to 31, and that shall be equation 5. So now let's solve the two simultaneous equations, equation 4 and equation 5. So first of all, I'm going to make a the subject in equation 4. And I can say that a shall be equal to 9 plus b over 2. So now substituting for a into equation 5, I'll have 6 into 9 plus b over 2 minus 16b is equal to 31. So next I can see that this 6 can divide this 2, and I will be left with a 3. So I'll have 3 into 9 plus b minus 16b being equal to 31, of which when I multiply the 3 into the brackets, I'll have 27 plus 3b minus 16b being equal to 31. So solve this further, and I'll have negative 13b being equal to 4, of which this shall give me b being equal to negative 4 over 13. So now to solve for a, I'll have a being equal to 9 plus times negative 4 over 13 over 2. So a shall be 9 minus 4 over 13 over 2. So when I solve this further, I'll have a being equal to 113 over 26. So now the center of the circle shall therefore be 113 over 26, comma, negative 4 over 13. So now I can substitute for a and b into any of the equations 1, 2, and 3, and I can actually find the radius. So I've chosen to substitute them into equation 1. So this is what I'll have. So simplify this further, and I'll have 1 minus 113 over 26 will be 7,569 over 676. Then 3 plus 4 over 13 will give me 1,849 over 169, all being equal to r squared. So when I add these two fractions, I'll have 14,965 over 676 being equal to r squared. Then when I actually solve this, r shall be root of 14,965 over 676 units, which is the same as 4.7 units. So now that I know this, I can actually now use the general equation of a circle to actually find the equation of the circle that we're looking for. So plug in for the values of a and b, and then put in the radius of the circle. So solve this, and eventually I've chosen to actually speed this up a little bit, but eventually your final answers should be 13x squared plus 13y squared minus 113x plus 8y minus 41, all being equal to 0. That shall be the answer that they wanted. Alright, so lastly I have an exercise for you. It's an exercise with one number from part A to part B that I encourage you to try out. So now when you look at this exercise, you can see at part A we're being told origin A And B, I believe by this point you've actually understood what we mean by coordinates of the origin. Remember, at origin is the points 0, 0. So that is very, very important, because you shall be using the term origin repeatedly in this section or in this course. Thank you so much for watching. Thank you so much for watching this video. I hope the video really helped you. If it did, feel free to share the video with all your friends and help as many as you can. And then if you really like the video, feel free to give the video a like or a thumbs up, and then tell me in the comments if the video really helped you, and I'll try to get time and reply to your comments. And then if you're new to this channel, I encourage you to join the community by subscribing, and then make sure to hit the notification bell so that you get updated every single time I upload a new video. Thank you so much for watching, and I'll see you in my next video.